Ladies and gentlemen, welcome to my channel. I am Zenelect, and I'm excited to introduce to you a guide on how to build your own Linux distribution in a virtualization environment. And the beauty of this is that it's free and open source, so it doesn't cost anything, and it is a portable system that anybody can use on Apple, Linux, Windows. It's a virtualization environment. So whatever you do inside that VirtualBox will not damage the host machine. And I'm going to take you through that guide on how to get it installed. So let's go ahead and do it. This is Linux from scratch, and this is the guide we're going to be working through to get our system built. And right now it is version 13. The development build, the new books come out every 6 months. So I'm assuming 13.1 will be out around September sometime. So we have enough time to get 13 built. And we're going to attempt to do this in this stream. We're going to attempt to get this built and running in this stream. So yeah, we're going to be using a cross-native compilation technique. So we're going to install our virtual machine or install our VirtualBox software, and then we're going to create a virtual machine, and then we're going to run a Linux ISO inside that machine that we get offline, and that will be our host. It'll be our Linux system that we use to build our LFS system with, our own distro. And so we're using a cross-native compilation. We go into chapters 5, we build the cross compiler, we build all the additional tools we need for change root, we build additional software for chapters 8. Everything up to chapters 8, not including chapters 8, is prep work for chapters 8. Chapters 8 is the final product. We'll run through this, get this all done, whatever we need to do there. And then we'll go into chapters 9, we'll do some configuration. And then chapters 10, we build the Linux kernel. And then we go into BLFS, because we got to get SSH, wget, stuff like that. That's beyond Linux from scratch. It's a different project I haven't discussed yet. But we got to get some additional software so that way when we boot into our system, we can SSH and wget software. It's just usual that you want some type of access to SSH and all that stuff. So, but first we need to get VirtualBox. So let's go ahead and this is VirtualBox. If you search VirtualBox, it's at Oracle VirtualBox, or the Oracle site is an Oracle platform. And so it's trusted. And you just click download, get it. Get the installer for whatever distro you got. I'll show you how to install that in a minute. And accept and download the extension pack. I already got this stuff. Next thing you need, if you're on Windows, you might need C++ redistributable, because that's a dependency of VirtualBox. VirtualBox will typically install it when you install it with the installer. But if you want to install it ahead of time, you come here to Microsoft Learn. Make sure you're at Microsoft Learn. And this is a Microsoft software, so you should be able to get this from Microsoft. Get it. This is the exe file. If you're on Linux, you might have to install the generic headers, stuff like that, to get your VM running. Apple, I'm not too sure about what the dependencies are for that, but I think you'll be fine. It's a pretty easy software to install. And we need a Debian ISO. I'm going to be using Debian. You can use whatever Linux system you want, but if you want to follow the tutorial, you might want to get the same ISO. So go to Planet and getting Debian, and I got the live GNOME. That's what I'm going to be using. And so you just click on it and download it, and then you'll have the ISO. And so with that said, we go into the downloads. This is the VirtualBox. This is the C++. I have to uninitiate. I have to uninstall it, and then I'll just install it. And it's installing. Uninstall. Okay, I got 2 uninstalls. Just cancel that. I don't need that. Close. Okay, so there's that. Now we'll install it. Just I agree. Install. You probably should have C++ redistributable for your Windows system anyway. And Python too, if you want Python. That's a programming language that's always useful. So I got C++ redistributable, close. Okay, so now the VirtualBox. So I gotta uninstall this. Probably gonna have me uninstall it. I'll remove it. And remove. Okay, finished. Now we're going to install it. So this will be the installation manager. And so I'm going to accept and accept. This warning network disconnection, what this is the VirtualBox needs to read the network card in order for that you to have internet inside the VM that you run. You're not going to lose internet. I never have. And then the missing dependencies if you need it. And then go ahead and just install it. And that's it. We'll start VirtualBox. And then you should have something like this. So yeah, the extension pack can be installed here. The extension pack you accepted and downloaded with the VirtualBox. I can uninstall this and show you guys how to install this. Just go ahead and load this up, install, and then you just drag this down. I agree, and jangling. And that's all she wrote for that. Now let's go ahead. We'll create a VM. So click new. And if you don't see this on when you first load this up on the right, you'll see an expert and basic mode down here underneath this balloon, this circle. And you just want to click expert mode, so you're in expert mode. So let's go ahead. I'm going to create my OS, and then I need to change the VM folder because I don't have enough room on my drive, or at least I don't want to put it on my drive. So I'm going to go ahead and just put it on a different drive. Okay. That sounds good. That should give me a chance to get that. My OS Linux, and then the ISO. Okay, so now proceed with unattended installation. It's got to be unchecked. The OS version, this is going to be 64-bit. And then the hardware and how this works. If I load up a calculator, every 1024 megabytes is equivalent to a gigabyte of RAM. So if I did 124 times, say 6 gigs of RAM is what I want. I got 16 gigs of RAM, so I have enough. 6144, that's what I'm going to put here for megabytes. And I'm still in the green, so I'm good. I'm safe there. And I'm going to bring this all the way up to the max on the green for the processors. Because I want to get the best of my processes. And then this use EFI is going to be checked. We're going to be building EFI. And I'm going to be allocating 100 gigs. So you probably don't want nothing less than 80. Just because if we go further into BLFS and build a desktop, you might want enough room to be able to expand onto. You can always shrink it down once it's built, but at the end of the day, you're building an entire system from source code, so you want to make sure you have enough room. Once it's built, you can shrink it right down to barely nothing. And so now we got our VM created. We got to go ahead and configure this. So yeah, let's go ahead and bring this up. I want to say 64 MB on the video memory. So how this works is, if you know anything about computers, you have a virtual IDE and a virtual SATA. The virtual IDE is, well, on your computer, it would be the CD-ROM drive on the side of your computer. That's an IDE controller. And so this is virtual. It doesn't exist on the drive, on the computer itself, but it exists virtually in this software. And we're housing the Debian Live ISO. And so the SATA controller is most certainly the hard drive controller, and it's housing my OS Linux virtual disk image at 100 gigs over here on the right. Will be booted into this live Debian ISO and interfacing with this virtual disk image in SATA. And then when we're done building our system and get the Linux kernel boot and grub set up and stuff on this VDI, we go ahead and remove this entire IDE controller. It's no longer needed unless we got to come back into change root. And then we boot into the virtual disk image and run our Linux distribution. And so if we click Debian Live on the right, you'll see live CD DVD. You want to check that. And this network, this is important. You got to be in expert mode for this. And so we'll bridge the adapter. That's a need. And you can try to run your virtual machine with your network adapter, but if it doesn't work well, just paravirtualize it right there, and you need to be in expert mode to do that. So yeah, let's go ahead and hit OK. And now this is key. Before you can try to run it, and if you get an error message when running it, it's because you probably have secure boot enabled in your BIOS. And because you're running a Linux system inside of your system, so it triggers secure boot. And secure boots ain't happening. Somebody might be in your system. But you're in control of this, so you know nobody's hacking your system, right? You're controlling all this, so you can go into your BIOS, into the security, and disable secure boot, and then just re-enable it when you're done building the system, right? So yeah, you will have to do that to get this running if it does give you an error message. And there it is. So right control letter C will scale your VM. And you might get a box that comes up, just do your thing and scale it. That gets you in and out of scale mode because we can't install the guest editions, which allows us to have full screen mode. We're on an ISO, so it's not possible. It is possible. I've done it before, but it's a pain in the butt. So we won't worry about that. We'll just scale it and change the resolution when we get into the system. It takes a minute for the splash screen. It's a Debian GNOME, so it's a powerful system. Powerful Linux system. Just takes a minute. Okay, so this is GNOME. It's GNOME Linux, and so the Windows key will be your best friend. These are the applications. We can actually build this desktop environment in BLFS. It's one of the desktops we can build. We can build either GNOME, KDE, LXQT, or XFCE. GNOME's always a fun build. I like building GNOME. It's always a fun build. So we'll go in, we'll choose dark style, no doubt about it. And we'll go into the settings. We gotta configure some of this stuff. The first thing I hit up in here is the resolution. Definitely want my native resolution. And then I go into power because I'm on a notebook. I don't want my VM blanking out. So I'm just gonna go ahead and hit that automatic power saver. And then I'm going to go down to the privacy screen. I can just turn this off. Why not? That don't need to be on. Then I'll go into system and I'll go into date and time and I'll set up my time zone because internet reasons. And you can interface with this directly. They got a Firefox web browser and a shell, a terminal. You can. I'm going to be entering SSH so I can allocate all my resources to the build. I don't want to bog down the ISO. It can be a pain sometimes. But if you want to interface with it yourself, that's fine on you. Whatever makes you feel more comfortable, right? Okay, so let's go ahead and open a terminal. We'll sudo -i apt install SSH and NetTools. That'll get us into the system. If you have an issue, it gives you a lock. It's the automatic updates. Wait about a minute and a half or two. You'll see a box come up, and then you'll be able to install your software. You can do an update if needed, but don't do an upgrade because you're on an ISO. This is not an installed system. And user is Debian's name. If you exit out of root, you have user at Debian. So we will most certainly PASSWD on user and set a password so we can SSH and pull our IP. And mine's 228. Let's go ahead. We'll open up a PowerShell, whatever shell you have to SSH with. We'll set this up right here on this side. And then what I do is, I forgot the IP, 228. So what I do is you gotta have SSH installed on your main system. And so what I typically do is SSH with the -o switch, using own host file dev null. And then I put the user and the IP. And the reason why I do this is because sometimes you get a certificate issue where it says somebody might be hacking your system. And what it's doing is it's obviously reading an IP that's already been made somewhere on the router. And it's trying to create a certificate that's already been made for an IP. So that solves that issue. It conflicts. What did I just do? And I think something happened. There it is. So yeah, that's the SSH, and then we're going to go ahead and bring up this Linux from scratch, and this is how we're going to be working. We're SSH into this right now, so yeah, everything I run in this shell, if you don't know, if you're not aware, you can run in this shell here. If you want to work with your VM, you just do it this way, and you set it up like that, you bring it up, you configure it. You can configure this, no doubt about it. You go into preferences. What I usually do is I turn off the terminal bell because it's annoying. I custom font this because I can't see it for hell. And I usually do about 18. And then colors, green on black, and then I do this, boom. There you go. You got it. Then you just go ahead, go here, close out of this, and you search for Linux from scratch, and then you're ready to rock and roll. Inside, and this is inside the VM. So yeah, you can do it this way too. Everything I run in this shell right here is going to be essentially what you run here. That's about all she wrote for that. And of course, this system is not meant to be powered down. So if you need to power the state down, if you want to save the system state so you can come back to it, just hit this X up in the corner and you'll get 3 options. And you just want to check save the machine state, save it, and then you come back and work with it later. But don't power it down, otherwise you'll have to reset up environments and stuff. Okay, with that said, we're ready to rock and roll. Okay. So, the first thing we're going to do is become root. I'm sorry, guys. I got to take a quick break. Don't go anywhere. Stay tuned. Don't touch that dial. I'll be right back. Okay, back and ready to go. Let's go ahead. We've set up everything. We're ready to work with Linux from scratch. So, if you want to know a little bit about the standards, stuff like that, architectures, you can build this on just about anything. The standards, you got the file system hierarchy standard, the Linux standard base, and the POSIX. These are standards Linux usually adheres to. Every Linux system has the same file system, stuff like that. You have distributions and then you have Linux. They all kind of coincide somehow through standards. Makes things portable, stuff like that. And you got the typography. We'll talk about that. And we move into the introduction. This is pretty much for developers who want to know, like, change logs, stuff like this, what's new since last release. Got some resources and some help if you need it, but hopefully you don't. These guys are very busy developing the new books. There's not a lot of them, they're all volunteers, so yeah. And then we move right into the introduction, chapters 2. Part 2, preparing for the build. Chapters 2, preparing the host system. I do believe I left the links in the description for some of the stuff. And we're going to start right on host system requirements. And so I already know what to do to get this right. So let's go to the shell, ln-svf bash on bin sh. And that sets sh points sh to bash. That's for the script. And then apt install wget m4 gawk bison auto make auto conf build essential is definitely needed, and text info. That'll get you off the ground with Linux from scratch. Pretty basic. Okay, so now we gotta set up the device because that comes later on. And so it's gonna be SDA because we're in a VM. And the VM only reads one device, and that's the virtual disk image we set up. So we'll write CF disk, and we'll just go in there. We want GPT. We want a new size, so we want 512 capital M, the type all the way to the top to EFI system. The next one will be a swap. I typically do 4 gigs for that. I don't need any more than that. The type will be a Linux swap. And then the last one, most certainly, will be the remainder size, and we don't need to do nothing with the type on that. We'll go ahead and write to the disk, and then we'll just quit. Now, if we do lsblk, you'll see 3 partitions set up. So nkfs-t vfat dev sda1 mkf, or we'll do mk swap dev sda2, and then we'll do mkfs-text4 dev sda3. That sets up the file system. If you go ahead and look now with a -f, you'll see that the SDA is now VFAT. I'll be referring to this as the EFI system. And SDA2 is the swap. And I'll be referring to that obviously as a swap, and SDA3 is the root file system. I'll be referring to the ext4 journaling file system as the root file system going forward. So with that said, we can go ahead now and run this shell script. And we should get everything checked out okay. Yep, and that's good. So that tells us we can progress forward in the book. And so we'll go to chapters 2, page 6. We will set this environment variable that points to the root file system. We will umask once we get it mounted, and I see 0022, so that's good. And then I'll echo my variable to make sure it's set, and it looks good. So we're able to move on past this part. Now we're going to go ahead and create the LFS directory and mount the root file system on that directory for accessing it. That's SDA3. So now if we df-a capital H on the variable, you'll see now the SDA3 is mounted on MNTLFS with 96 gigs available. So we're able to move on in the build. And moving forward, we will make sure the LFS directory is owned by root. And we'll enable the swap, which we only need to write swap on dev SDA2. And that should, if we write swap on, you'll see it's the swap partition is now enabled. So looking at this going forward, you'll see now swap is active and enabled. SDA3 is indeed mounted on MNTLFS, so we're able to move on with that. And so we're going into chapters 3 now. So we gotta create the sources directory, which acts as like the second download directory. We're gonna put everything we retrieve from the internet in this directory. We gotta make sure we can access it with an unprivileged user. We're gonna create chapters 4 for the cross build, because we need to set up a specific environment for cross compilation. So what sources is always going to be owned by a root. And how do you access a file or directory with owned by an administrator with an unprivileged user? Well, you do that through writing read-write executable for owner, group, and other, and writing the sticky bit. So if we go ahead and do an LSLA on the variable, you'll see sources now looks like this, still owned by root. And now we got to gather up the software, and we're on 13, so I'm going to use the website mirrors just because it's easier. So I'm going to go back to the beginning of the book, go to the website mirrors, go to some file mirror that works, go in here and just retrieve the tar file. And we got to get wget if we haven't got it yet, so let's just do that. We already got it, good. So we will cd into $LFS sources, and then we will wget this tar file, and that has all the software in it that we need to build Linux with. And additionally, we're not done yet. We got to go to kernel.org, because kernel.org houses the firmware we need. So let's go ahead and get Linux kernel firmware and go down here. So yeah, I got a little bit to go on the download for this. Let's hope it downloads quite quickly. And you want the newest version of the firmware, so let's do it. Well, I happen to not have to wait too long, so I'm happy about that. That's a good time for me. Sometimes it takes a little bit of time to retrieve this stuff, but I lucked out. So looking at my sources now with LS, you'll see the tar file on the Linux firmware. Great deal. I'm going to copy this MD5 sum, and then I'm going to go ahead and tar. This is the tar command. You'll get very used to this. Tar-xf on the LFS packages. Tab will autocomplete so you don't have to type it all out. And let's go ahead and extract this. Okay, now we're going to go ahead and use the move command, and we're going to go ahead and just type 13 asterisk into current directory, which is dot. And then doing an ls, we have everything there. So let's run the MD5 sum. Everything checks out okay. RM on MD5 sum, RM on wget list, RM on check.sh. We're cleaning up now. RM RF on 13 without the asterisk, just a /, and RM RF on the LFS packages. And I'm gonna RM RF, and this is optional .. lost and found because I don't need it. We're good to move on from this point on, I think. So yeah, we'll go ahead and make sure everything's owned by root in sources. And now we're able to move on from this part. This is all the packages. We'll get used to them. Needed patches. We'll get used to them. And now we're in chapters 4, page 2. We got to create the first forms of our file system that we're going to be building our distro in. That's going to be created on $LFS because that's where the root file system is mounted. So doing an ls on this $LFS, you'll see now you have the first forms of a file system. So we'll move into creating the LFS user. We need to cross compile within chapters 5 and 6. With the shell, we just pulled all this, so we set it up with. I'm not going to go into the in-depth details of what's going on. I just want to keep it basic for you guys. So we'll go ahead and PASSWD on the LFS user and just create some basic password. If I can type right. And then we'll go ahead and chown some of them directories. So we'll do an ls-la on $LFS, and you'll see now that etc lib64 tools usr and var is now owned by the LFS user. That gives us access into them directories. When we cross compile, sources is still owned by root and always will. So now let's go ahead and su into the LFS user. So clear this screen, and now with the LFS user, we're not done yet though. Not done. Now with the LFS user, if we run an env, this is not what we want for an environment. We got to make sure we have an environment for cross build. So we set up the profile, and then we set up the bash rc, and this will be sourced, and it most certainly will contain all the variables we need for chapters 5 and 6. And now what we're going to do down here, all the way to the bottom, we'll just cat in this make flag, because that's where you're going to get the best of your processors. And then up at the top, under this important note, now I'll show you what's happening here. If we exit and then su back into LFS and run an env, we still have this Debian change root, Debian change, all that in the PS1's got to be cleaned up for the risk of overlap. We want to make sure that our systems, our distribution is not going to overlap onto this Debian system. So yeah, that's not good to have that in your environment. So exit back into LFS, root. So you're in root now, and then you're gonna run this, and then you're gonna su back into LFS, and this is what happens. You become completely clean of anything regarding Debian, and all you have at the command prompt is just LFS $$. And that tells you you're good to go forward. So now we're going to go ahead and go into chapters 5, and this is where the fun begins. So this is past one of binutils, and this is going to be the cross assembler and linker that is needed with GCC to build the appropriate software. This binutils and this GCC right here is what's going to build the remainder of chapters 5 and chapter 6. Okay, so just keep that in mind. Let's go ahead and cd into $LFS sources, and then tar xf binutils. Okay, now we'll cd into binutils. We'll mkdir on build, cd into build. So we're in a build directory now, which is required by the build. And then we'll just run this configure and configure for build. And that's it. And we're off and running. So let's go ahead and just run make and make it. And that's our cross assembler and linker we're going to build chapters 6 with, and the remainder of chapters 5. binutils is a major dependency of GCC because it contains the standard linker and assembler. This is not to be confused with the dynamic linker. The dynamic linker, or also known as the loader, comes with glibc. This is a standard linker, and the difference between them is this one specifically links object code at build time with the compiler, and the one with glibc links libraries to applications at runtime. So don't get them confused, and this is how this works is GCC is a compiler. It compiles the source code you see before you into assembly language, which is the lowest level language, and then it passes it off to the assembler, okay, which is right here with binutils. And then the assembler assembles the assembly language and then hands it off in object code to the linker to link the object code into the application. So yeah, it's definitely a needed software for GCC, most certainly. And then it's got other software for debugging object code and disassembling object code, and there's all kinds of good stuff with binutils that comes with binutils. And so let's go ahead. We got the make done on binutils. Let's go ahead and make install, and that went just fine. So now we're on to the cross compiler. And we'll back up a directory, cd backup, and rmrf on binutils / clean that up. You don't need to put the / I do just to make sure RM knows that it's a directory, but it's not needed to remove binutils. And then we'll tar xfgcc. This may take a little bit of time. This is a massive machine. Okay. We'll cd into GCC. Okay, we're in GCC. So we got the math libraries, MPFR, MPC, and GMP. These are needed for the build of GCC. We don't have them independently built yet. We don't build them until chapters 8. So we don't have our own GMP, MPFR, and MPC yet. So we got to extract them and put them into GCC's directory for the build of GCC. So that's what we're doing here. Then we got this case command. This is for LSB compliancy, I do believe. When I go in here and read up on Linux 64, that's what they're talking about, is LSB compliancy. They want your libraries, your 64-bit libraries in lib, and then have them symbolically linked. So yeah, let's go ahead and do this right now, and then we'll go ahead and mkdir build and cd in the build. And this is a hideous configure script. It's really not bad at all. Just disables everything because we don't have the standard seed library yet for compatibility and what it needs to build all this stuff. So this is going to be a basic raw GCC. It ain't even a no C because we ain't got it yet. We will build glibc on the next few packages to come here, and we'll collaborate it all together in chapter 6. You'll see how it comes together if you keep following. But this GCC is an inadequate GCC. It's a half-built GCC just across compiled chapter 6. Then we enter change root, and I'll show you in chapter 6 we rebuild pass 2 of GCC and bin utils. And them are the linker and assembler and compiler that we compile with this compiler. We're trying to drift away from the ISO as much as we can. We need a cross compiler to cross compile a compiler, and this is what we're doing here. And I'll show you a little bit about what happens here. If I can get to the top of this. This build system type, host system type, and target system type, these are actually pretty critical in knowing you're cross-compiling. The build system type says the compiler you're building this compiler with is running on the Debian system, because PC Linux is saying it's running on Debian, and it is, because the compiler we installed with Build Essential just a few minutes ago is the compiler we're using. We're using a compiler on Debian to compile this GCC. Now, the host system type is PC Linux, because this is not meant to run on our LFS system. This is meant to run on the Debian system. However, the target system type is specific to GCC and tells you it's LFS Linux GNU, so it's meant to build code for the LFS system, and that's what we're going to be doing in Chapter 6. Is building software to run on our LFS system. So believe it or not, the remainder of this chapter and chapter 6 will be all collaborated together so we can enter a change root, which is essentially like booting into your LFS system without using grub. And so yeah, chapter 6 is most certainly the first forms of your Linux system being built. But it's not done, it's unfinished. We got to go into chapters 8 and expand onto it like a balloon and just make it robust and fluent. So yeah, let's go ahead and build this compiler. It's a pretty big compiler, so in VirtualBox with what I got for resources will take probably up to 9 minutes, probably close to 10 minutes, I'd have to say, to build. It is a long process, but we'll just listen to some music while it builds, why not? And I'll even time it. If you want to time it, you just run make, and then just make it. So I'll be back with you guys when it's done. Okay, so GCC has built successfully. Let's go ahead and do a make install. And that's the cross compiler for you. Now, because it was built inadequately, we got to set up the limits file. This limits file references another limits file that comes with glibc. And we don't have glibc yet. It wasn't created on the command line with GCC when it built it. So we got to manually create it. It's always good to see the compiler build successfully. If if you've made it past the GCC compiler, you must be doing something right. If you didn't, don't give up. Try it again. Okay, so there's that. GCC is done. Now we're going to go into the Linux API. We're going to be building glibc on the next package, which requires a Linux kernel. We can't build a Linux kernel because we don't have enough in our system to build it right now. It requires a bunch of stuff to get that off the ground. So we got to extract the API that's needed for the glibc build. And the reason being is because everybody in the development world will clearly tell you that glibc acts as a wrapper around the Linux kernel, and it speaks between the operating system and the low-level kernel. So yeah, without both ends, it's not going to be able to run right. So we definitely need to extract this API, and that's going to be make sure you get the kernel and not the firmware. That's important. Then we'll go ahead and run, we'll cd into the Linux kernel. And this will take a little bit of time because it's a massive kernel. And we'll make mr proper. That will do essentially a make clean on the kernel. And then we'll go ahead and just extract this API into sources. Not sources, USR include. But it's going to be mntlfs USR include. If you look at the output of where it went from a relative directory, USR include, which is in Linux directory, into mntlfs USR include. So that's now we got an API. So let's go ahead, we'll remove the Linux kernel, extract the directory. And then we'll go ahead and extract glibc and build glibc. That's all she wrote. We need these compatibility symlinks definitely for the build. It won't get off the ground without it. We have an FHS patch. There's the file system hierarchy standard. Obviously, there's a patch in there that needs to be ran for the FHS compliancy. Then we'll go ahead and mkdir and build, and then we'll cd in the build, and we'll make sure ld config and sl in have the appropriate install directory, and we'll go ahead and configure this build. So let's go ahead and just configure it. And this might take a little bit of time. It's a massive library. So on Windows, if you guys are new to this, on Windows you have DLLs. Well, these are essentially the DLLs of Windows. They're just Linux DLLs. We don't call them DLLs in Linux. That's all that. But it's equivalent to the same thing. So it's definitely needed to get a system off the ground. It might take a little bit of time. So yeah, I'm going to jam again to some more music. And we're back. So glibc cross-compiled. So I want to mention to you guys the difference, the transition here is when we built binutils in GCC in Pass 1, we used the compiler that we installed with Build Essential with APT. Now we're using the cross compiler that we just compiled to build all this other stuff. And as you can see, we have the distro variable now that points to mntlfs inside of the install. And that's going to be what spits it into mntlfs. So throughout chapters 6 and the remainder of chapters 5, which is only the C++ libraries, you will see this distro variable inside the install, so make sure that gets ran. Otherwise, you'll have an issue. And then we go ahead and fix the hard-coded path in the executable loader in the LDD script. It's USR lib. We're removing USR and just leaving /lib. Obviously, we want this executable loader to point to lib, not USR lib. Just the way the system works. Okay, so now we're going to test our stuff. So let's go ahead, we'll echo this, and we should get lib64 LD Linux, and we do, so we're good there. Now we should get these 3 object files succeeded. and we do there, so that's great. Then we got some directory paths. We got to make sure these come out right. And they do. We got MNT, LFS tools, lib, GCC, x86, blah, blah, blah. We got all what we need. 3 directories. It's looking spectacular. And then we got some more directories. We're going to disregard Linux GNU in this. And that looks great. I'm pretty much convinced that that's what it is. And then we'll go ahead and attempt to open MNT, LFS, USR, libc. So we're attempting to open libc, and we got it open. And the last but not least, we're going to try to find the dynamic linker. And it's right here, so that looks all good. I'm happy with that. We don't need to remove dummy.log and all that stuff because we're going to be removing glibc automatically right now. So rmrf glibc, and that's a past history now. So let's go ahead and we'll extract GCC again because the C++ libraries are a part of GCC. These are needed for the build, obviously. You need some type of C++ libraries. And we'll just go ahead and mkdir on build and cd in the build. And then we'll just go ahead and build the C++ libraries. That's it. And that's it for chapters 5. So then we go into chapter 6. And I'll explain that when we get there. I don't want to rush ahead of the game. I just want to get the C++ libraries built right now. And I'm not going to say this every time. It's a configure, make install. That's what we're building software, so you know that's a must. You'll see the make install. Just make sure you're running the Distro variable as we go forth. And at the bottom, we get to remove some archive files, which could be potentially harmful to the cross environment. We remove these throughout chapter 6 also. And that's it for that. Okay, so yeah, we're going into chapter 6. So, what this is in chapter 6 is when we get into chapter 7, we're going to be entering a change route, which is essentially like booting into this system without grub. We change route. We are only using the kernel to set up the interface, but we're actually live in the system we're building now. Once we're live in it, we're no longer going to have access to the Debian software, right? Because we're live in our LFS system now. So we're not going to have access to tar, make, all that stuff we have now. We need that stuff when we enter change route. So here we go. We're going to build the additional software and its dependencies for the live environment when we change route. And at the end of chapter 6, we build our bin utils and GCC with the cross compiler we built in pass 1. And then we're going to enter change route because the compiler we built in pass 1 isn't meant to run in LFS. It's just meant to run build code for LFS, right? It's a cross compiler. It's not meant to run on the LFS system. It's meant to cross compile for it. Now we're going to cross-compile the compiler and bin utils at the end of chapter 6. So when we get into change root, we're able to run a compiler. If we didn't do this, we wouldn't have a compiler to run, to build in change root. This is just how cross-compilation works, right? At the end of the day, people may ask, why don't we just build the compiler? We can't. We need a cross compiler to build this compiler. So it's just the way cross compilation works. So yeah, that's it. We can't run the GCC that we installed with Build Essential at the beginning to run code for LFS, to build code for LFS, because it's not set up like that. We got to go ahead and transition, and the whole point in this is to remove the ISO at the end and boot into the disk image. Not the disk image of, the virtual disk image is what I'm referring to, which is the where. Essentially, what it is everything beyond MNTLFS is on your disk image, because that's where the root file system is mounted. So yeah, we're building in that directory right now, and then we're going to enter live environment and build and expand onto that in chapter 7 and 8, and then we're going to build the kernel and boot into this, and the Debian system goes bye-bye. Okay, it's no longer existing, and if we have any references to the Debian ISO when we boot, we're not going to boot it. It won't run, or it won't run right. So yeah, at the end of the day, this is just the steps we take. So let's go ahead and go forth in this. We'll get M4, which is a macro processor. It's probably not needed directly, but I'm pretty sure if we're building it, it's a dependency of something we do need. And you'll see this quite a bit. It's just configure, make, and make it so. Can't get no easier than that, right? I mean, it's simply what it is. Speaks for itself. We're building software. We're going to configure. We're going to make and install, and move on until we get the system built. At the end, we got to configure the system and do all that good stuff with it, and configure the kernel, obviously. So yeah, it's going to be a good time. Alright, so let's go ahead. We'll do this, and we'll just, I paste it in there. Bash is a good shell. It knows it goes into the buffer. And that's it with that. So yeah, we'll go ahead and remove M4. We'll get ncurses. Ncurses deals with character screens. We need it for the kernel to run make mr proper. Make menu config. Character screens are isolated to your terminal. They don't have a GUI. They're just pretty much arrows and enter and tab and whatever you can do with it. But there's no mouse. It's just a character screen. So it's not an active GUI for a mouse. And so that's just how that works. This the libraries, this software is the libraries that deal with that, and this is what we're building the tick program first in MNTLFS tools for the future use of the tick program. Obviously, it doesn't get built. The tick program on the build host, first run of the phone. Yeah, so somewhere it doesn't get built. And so we have to build it manually. And now we're going to configure the libraries. And this doesn't install. We don't install the tick program. Oh, we actually do. We install it in tools bin. Yeah, so yeah, it's definitely installed. and then we go ahead and run make, and then we run the make install, and we fix up. There are two sets of libraries. There is the wide character and the regular character, and we want to use the wide character. You can pretty much say that the wide character are the regular character. They're just the regular character on steroids. So we want to set up the wide character because a compatible as regular character is the wide character, just has more capability. So yeah, at the end of the day, we want to link all that stuff to make sure we're using the wide character libraries. I do believe that's what that is right there. And the reason why I say that is because I clearly see the symbolic link with the W. That's the wide character linking to the regular character. So, I mean, that's what I see when I look at that. And then we'll move into Bash. And Bash is the shell we're going to be using. Okay, so Incursus is done building. And so let's go ahead and get Bash. And then we go ahead and make Distro install, and at the bottom we got to point sh to bash. This is mntlfs bin sh. So this is our bash that we're doing this for. When we did it at the beginning, we were doing it for the Debian system. Now we got to make sure we do it for our system, because we want to make sure sh is compatible with bash. And let's go ahead and run the make on this. Then we'll run the Distro. And then we'll go ahead and fix up this. And then we should have a shell when we get into chapter 7. I think we do fix up this shell to run a new shell. And we'll run an exe C on bash, and it will run this shell. So yeah, you definitely want this link. It's a must to get it running right. Every command is essentially very critical to getting the system running right. So yeah, this is core utilities. This is nothing specific. It's a collaboration of small programs that just never got their own tar file, so they collaborated them into the core utilities, which is what it is. It just houses a bunch of core utility programs, you know what I'm saying? So yeah, we got a patch on this, so we'll just go ahead and make sure we get into that. And then at the bottom, we got to move the change root program over to sbin and fix up its man page. Now remember, this is for our LFS system. We're going to be change rooting into this very system we're building now through the Linux API and the glibc and C++ and all this linked against that. We're able to enter an environment. It's pretty cool how it works. Got to get there though. We got a minute to wait for the compiler to compile. And when it comes to the install, I'm just going to pull it from history because it's easier for me. So I'm just going to locate that and run that. And I'll put that into the clipboard and paste that in there, move into diff utilities. Diff utilities tells the difference between files and directories. Must, need in a Linux system. No doubt about it. I mean, the system needs to know the difference between files and directories. So we need this one. Okay, so that's pretty good there. And then we're on the file. File tells the given extension of a file, so that's a must. You need to know what you got for a file. And we'll most certainly build the same version of file on the build host, but we won't install it. We're just building it for compatibility issues with the file we got now. In order for it to run appropriately, we need to have the same version of file on the build host. It's probably a build version check that triggers something in the configure. I don't have a clue, but obviously we need to build the file program on the build host because it's got to be a version check issue. Obviously, we need the same version of file on the build host to build file adequately for our LFS. So let's go ahead. We're still on diff utils. We got to make, and then we just run the install. This shouldn't take too long. And there's that. So diff utilities is done. Now we're on to the file program. We'll just run this. Now we run down. We got to configure the program for our LFS system. So we're just going to go ahead and configure that. I just throw it right in the buffer. I don't care. It works for me. And then we'll go here like this. We'll run the make with the file program in the make so it can find it. And then we'll go ahead and run the Distro and remove an archive file, and that's it for file. Not too bad, not too bad. And that red lettering you just saw, that was the archive file, the relinking warning it triggers before we remove it. So that's fine, that's safe. Now we're on to find utilities. Find utilities, well, it's got to be a dependency, indirect dependency of something we need, like Gawk or whatever's coming next. Probably don't need find utilities directly, but it does search your directory hierarchy recursively for whatever file you might be looking for, and it does have a locate command, a database, so you can search to a database to find it faster. It's a great program, but am I ever going to use find? I might if I want to find something. I'm going to use it, but I'm pretty sure we're doing it indirectly for a dependency of something else. That's how it works. They all coincide with each other. They all depend on each other somehow. So now we're into Gawk. So Gawk is a text manipulator. It's actually a pretty cool software. It's kind of like a a brain in itself. It can do calculations when you run it through its syntax and stuff. You can do all kinds of crazy nonsense with it. It's a great software package. Once you get used to, it's GNU awk, it's awk, it's GNU awk, it's gawk. At the end of the day, it's an amazing software package, but really its true purpose is just to manipulate files. So if you got a source file and you want to change something and you just don't want to go in there and recursively look for it, you can run gawk with a pipe and find or whatever you want to do with it, and it will just work. And you got to remember, developers are like path of least resistance. You know what I'm saying? They do things so they can add ease, so it's not so complicated. Otherwise, we'd all be still working on assembly language, and that would suck. So find utils. We'll build this, and we'll run the Distro, install on it, and move into gawk. Okay, find utilities is done. Okay, gawk. Oops. And we got a set script to make sure some unneeded files don't get installed. Some unneeded whatever it is. And then we'll go ahead and configure this. And we'll make install, and then we'll just move into grep. Grep is you can grep out. It's a very convenient software package when used with a pipe. You can grep, like, say if you got a source file and it's like 300 lines thick and you don't want to find it recursively in the file wherever you're going, you can grep that out in the file by using the grep program. It recursively searches any text file or any type of source file, whatever file you want it to grep out, and what it does is it recursively searches the file, finds what kind of input you give it, and then it gives you the output of what you're asking for switches. So instead of recursively looking through a file when you're looking for something, you can grep something out with this program. So you're not recursively looking yourself. Grep does it for you. It's actually a pretty nifty software program. I've used it a couple times. It's not a bad program. Let's go ahead and do the install on this. And we'll go ahead and remove gawk. And grep. Let's go ahead and get grep. That's just to make install. And now we got gzip. Gzip is a compression decompression software. It yields the lesser of the bunch, but it is actually the fastest. Because, well, in encryption and when you're compressing something, what you're doing is you're shrinking a size. And so at the end of the day, if it's more secure with the encryption, then it's going to take longer to encrypt. And gzip isn't the best encryption, but it is quick. It works well when you're just trying to get stuff done. So yeah, we use it a lot. It's in throw sources. We have some gzipped files and sources, so we definitely need gzip so we can extract our files once we enter change root. So that's why we're getting that here. That's pretty much a given. And we'll do an install. And now grep is done. So yeah, we're moving along a little bit at a time. Grep is good. Now gzip. And we'll get gzip. So the algorithm of gzip probably doesn't yield the best algorithm, but at the end of the day, uh, I like it. I will always stick with XZ. I think XZ is one of the better ones. It yields the best algorithm in my book, and it is a nice software. There's a bunch of decompression, compression software that we end up getting throughout this build. In chapters 8, there's like probably 5 or 6 of them we get, but probably just about all of them, I would say, if not all of them. And there's quite a few. There's ZSTD, there's BZip2, there's GZip, there's LZ4. There's all kinds of them. All kinds of them. But we need them because we're going to be using a lot of software that may be compressed with that stuff, and a lot of that stuff may be used with a kernel at boot. Who knows, you know? So yeah, we ran the make. Let's go ahead. I think either LZ4 or ZSTD now extracts the kernel. I don't know which one it is, but it's one of them. So yeah, it's they're all needed, one way or the other. So yeah, gzip is done, and now we're on make. It's a build automation tool. It's what builds our software. If you're asking yourself, well, why are we building it? It already works. Well, that's the whole meaning of what we're doing. The make we're using to build software now is on Debian. We're not change root yet. We need to have make when we enter change root because all the software on Debian takes a back seat. So let's go ahead and build our make for our change root. And then we'll move into patch. Patches are given. It patches files. Okay, so we got this. We're good. So we got the make going down here. Make is done. Now patch. So patch, we need patch. Patch uses a few different things when you're making the stuff and stuff like that. When you're making patch files, it uses different software. It's all this software kind of collaborates together, and that's how it works. One software helps assist another software. That's what creates the system and glues it together. So yeah, patch is a very nice software. It helps patch files when in need. And we're going to need to because we got patches that we need to patch. Software packages that we need to patch in chapters 7 and 8, or at least in 8. I don't know about 7, but we need patch, no doubt about it. So obviously they gave it to us in chapter 6. We must need it for something in chapter 7, or in the beginnings of chapters 8. Okay. So patch is done. Now we're on to sed. Sed is, well, they call it a stream editor. That's what that means. But at the end of the day, breaking that down, what it is essentially a comparison of Gawk. It manipulates text files. You give it an input, it gives you an output. So yeah, we use sed a lot in the book. You'll see sed throughout the book. So yeah, we definitely need sed to run sed scripts. That's what sed does. It runs sed scripts. It uses regular expressions, and it's just a mess sometimes when you get into sed scripts and figuring out how many backslashes you need in it. I mean, good luck with that. It's a very complex software because it uses regular expressions, which is all shell scripting and stuff like that. But if you're just doing a simple go into a file and modify it, if you got like say a source file that has 300 cat words in it, and you want to go in and change all of them to dog words, then you use sed to go in there and change them all, so you don't have to recursively go in and change them all. It's actually a pretty nifty software package. It's not bad at all, and it's used quite a bit in Linux when you're trying to modify stuff quickly. And so it's just a simple fix. First, it's another way of running a patch, I guess, if you will. It just depends on what you're doing. It's what we use. So yeah, you'll see it throughout the build. Set scripts everywhere in this book. And then we have tar. Tar is an archiver. Um, we use it to extract the files, so that's a given. We need that in our change root because we need to extract our files. And then we have XZ, which is the last compression software before binutils pass 2 and GCC pass 2. We need to get this because we got to extract some files in chapter 7, which is going to require XZ. That's pretty much it for the basic system that we're going to be change rooting into. Okay, so there's make and then the install. Not XZTAR. Okay. No XZ. Alright, good deal. Okay, we got the last archive file. Well, binutils might have some. And that's it for XC. Okay, good deal. Now we're on the bin utilities, pass 2. So if you've been watching, you kind of know what's going on. So I don't have to explain it again. We are building bin utils for our LFS system with the cross compiler we built in pass 1. We got to make sure there's no linking on the host system. So yeah, we're going to run that said script. And then we're going to run build and cd in the build. And then we're going to just configure this bin utils. And boom. Okay, let's get it done. Okay, so it built fine. That's good to see. Let's go ahead and run the make install and remove some archive files and static libraries. Okay, let's go ahead. We'll clean up bin utils and move right into the compiler. So boom, shakalaka. So if you remember what I explained to you about the last compiler when I showed you the build system type and the host system type and the target system type, well, I'm going to show you the difference here now in the GCC compilers. So once again, we got to extract the math libraries because we still don't have them independent. We got to go ahead and make the default directory for 64-bit libraries to be lib again, and then we got to additionally set up POSIX thread support. That's a must. You'll get an error message when you go to build GCC in chapters 8 because we got to build it again. If you don't get that right, you're going to get an error message. So let's go ahead and mkdir on build, cd into build, and run this command. And now I want to show you the difference here. On the first pass, the host system type was PC Linux GNU. Now it's LFS Linux GNU, and that tells you, or tells me, that this GCC is most certainly meant to run on LFS. The first time it was PC Linux GNU for build, PC Linux GNU for host, LFS Linux GNU for target. That told you it was a cross compiler because it was made to build code for the LFS system. But this one is a little bit different because the build system type is PC Linux GNU because a cross compiler is running on Debian. It's not running on our LFS system. It's building a compiler to run on our LFS system, which is what it's doing. The host system type is LFS Linux GNU, which tells you, boom, this compiler is going to run in change root once we change root into our LFS system. And it will also build code for LFS. So this is the compiler that will build chapter 7 and chapters 8 up to when we build over itself in chapters 8. So we did the configure. Let's go ahead and time it. I'm assuming it's going to take me anywhere between 15 and 20 minutes on average, I guess. It's a pretty big build. It is a compiler, and we're building it again. So if we have no issues, we will most certainly be running into chapter 7. There we go. We're off and running. Okay, so GCC Pass 2 is built. 16 minutes 48 seconds. So let's go ahead and do the install on this with the Distro pointing to the MNTLFS variable. And then at the very bottom, we got to point CC to GCC. And that's it for GCC Pass 2. So if you've made it this far in the build, congratulations, you can proceed on. So now we're into chapter 7, and what we're going to do here is enter change root. So let's exit. Well, let's wait for this to get done removing. Okay, now we'll exit back into root. We'll echo the variable, and that's still exported. So let's go ahead and chown. And what we did was, if we did an LSLA on $LFS, you'll see everything's owned by root again. So LFS takes a back seat. At the end of the day, everything we did in chapters 4 with the environment and the LFS user is now null and void. So let's go ahead. We'll set up the directories we need for change root, dev proc system run. We'll mount bind / dev to mntlfs dev. Populate that, and then we'll go ahead and set up the rest of our virtual kernel we need. And down here at the bottom, we have an if command with a mount in it. And that's it for that. Now we're going to enter change root. So watch what happens here. We are root Debian right now. And now we are LFS change root. I have no name, so we change rooted into the system we just built. And that's how that works. And now we're going to populate the rest of our file system with all the other directories that adhere to FHS. So now if we did an ls on /, that's our LFS system in a nutshell. Instead of the variable now takes a backseat, everything that we just did up to this point is now null and void. So we're going to go ahead and proceed on. We did all that to get to this point. So let's go ahead and we'll run the symbolic link on mounts. Been in the book since the life of it. It's just a historical symbolic link. Then we'll create hosts, PASSWD, and group. These 3 files will be called from the build of some software in chapters 7 and 8. And we need these set up. We don't typically need to modify them unless you know what you're doing. But they're all set up to work right out of the box. And I'm going to skip this tester because I'm not testing my software. And now here, the exe EC, we're going to change the command prompt from I have no name to root. And now we're root. So now we're good to go here. We'll cd in the sources, get ready for that. And the last thing we got to do is create some log files. And that's it for that. So now we got log files. And now we're going to move into get text. These are just prerequisite software that we need for the beginning parts of chapters 8. And get text is for internationalization and localization. It's so people can program software in their native output. So that's what this does. It's used within Tool. We will be getting that shortly. in chapters 8. And instead of installing this, we're going to just copy the programs we need right now. We'll be rebuilding this in chapters 8 and getting the install done. But right now, we only need message format, message merge, and xget text. Okay, so the next one is Bison. Bison is a parser generator. It's Yawk. Yet another compiler. And now instead of the Distro, we're going to be doing just an install. Okay, so yeah, now we got Perl. Perl is a programming language. And then Python. Python is another programming language. And they're just developmental languages that people use in development to build stuff. They have different purposes, different meanings. It just depends, and obviously personal choice. Whatever you want to develop in, there's all kinds of different uh, software programming languages. We need it. We need Python and Perl for chapters 8. And then text info. Text info is for info pages. They're a form of documentation with Linux. Then after text info, then after text info, it's util Linux. And util Linux is it's like core utilities, just another utility Linux. It's got a bunch of software that never got their own tar file. And so they crammed it together in what now is util Linux. Between core utilities and util Linux, that gives you pretty much all the basic stuff you need to run a Linux system. So we're gonna need definitely this, no doubt about it. Don't worry about the no such file directory on that. As long as it installs, it's all that matters. It's probably a known thing that LFS talks about somewhere. Util Linux, and we'll create the hardware clock directory. Oops, that's not what I wanted. And then we'll go ahead and configure this. And make install, and then we're done with chapter 7. Okay, good deal. Now we're gonna clean up the documentation. We'll rebuild it in chapters 8. And we'll clean up some more archive files. And I'm gonna keep tools until I boot the system. I'm not backing it up. I'm in a VM. I'm gonna back the entire VM up if needed. Now we're on chapters 8. And so I need to let my voice rest because I'm starting to lose my voice. So yeah, I'm gonna have to call it good here. This has been a good journey. If you've made it this far, congratulations. You are now on chapters 8. I most certainly will be back shortly to finish up this build. So stay tuned, like and subscribe, and don't forget, keep dreaming big Linux, and I'll see you guys on the next stream.